Okay, I'm gonna start explaining my project today. So the objective of this, my current project is to study COVID-19 outbreak with the help of some basic visualization techniques and compare the countries, the severeness of this virus across the countries in the globe, and perform predictions and time series forecasting in order to study the impact and spread of COVID-19 in next coming 14 days, which is 2 weeks. So the data set I have chosen is from Kaggle. This is provided by Roche Data Science Coalition, and it's been updated on daily basis. And every day they've been increasing. They update their data set with increased number of confirmed cases, deaths, and recoveries, and the country of each confirmed case, and few other features. It has 8 features in it. So that's about the data set. And I did this project in 2 different parts. In the first part, I basically tried to visualize the entire data set to clearly understand the current facts. And so this is the first part of the project. So what do we know until this point is the risk and seriousness and death from COVID-19 rising with age. So I first wanted to uh, uh, answer a few key questions, and like the demographics of the people who are under, like, severely under risk for this virus. But this is so limited to the age and place of the people. I've not gone to so many other details. It's just few demographic details. Uh, so this is a data set that I've taken from, and this is the basic. These are the basic features it contains, like the observation date of each confirmed case, and the province and state, the country, the confirmed case, deaths, and recoveries. So if we go to the further analysis of data set, um, I just wanted to count the number of countries that are actually impacted. That is 197 as of 26th April. And so I just, and then I have plotted plotted the severity of each country with the different colors, as you can see here. And then the observation, the spread of deaths, like the bar graph is about the confirmed cases, and this is about deaths. As we can see, the as you can see, the severity is mentioned in different colors here, and this is just using bar graphs, and these are the confirmed cases compared to the deaths, and these are the confirmed cases compared to the total recoveries. As we can see, the recoveries are more than deaths, which is good. And the population who are at greater risk. These are the list of the countries who are in the top of the list. But within the same is mentioned in the graph, and these are the deaths versus date ever since the COVID has announced as a global pandemic. So we have taken, since the date, we have I try to compute the number of confirmed cases each day. So as I said, this this part is mostly about visualization, which population have contracted and required ventilators. So in this, I have tried to estimate the shortage of ventilators, as this is the big issue right now. And these are the other, some of the few plots that I've tried to visualize. And then the conclusion is, as we are short of ventilators and there's a need to um, improve the number of them in order to save more lives. Okay, and I tried to answer this question, but this particular data set is have some constraints. I mean, this does not have the sufficient data that I could answer this question. So I am in search of other data sets to answer this, which has to be still done. So I have So this particular question, I have used multiple data set files instead of just one. There are like eight files under this folder, and I have tried to concat or different columns from different files, and concat them and combine them to be used here. And so the detailed, these are some unnecessary, this is more like data cleansing and data exploration, which demographic factors play a role in transmission across population. Role of temperature of the climate in the spread of COVID-19, analysis of temperature in confirmed cases. So I had conducted hypothesis testing for temperature, whether the higher, like the increased temperatures would really um, impact, lower the risk of COVID-19. And in my hypothesis testing, since the P is greater than 0.05, we can safely accept that our hypothesis that temperature does affect COVID-19 and remains same over the population. So we can like statistically accept that the effect of temperature on the spread of COVID-19, and dependency of COVID-19 spread on certain health demographic figures, like especially I try to do this especially for USA. Um, this is just, and then the spread of COVID-19 across US countries have any relation with health indices. So these are the few other prior health indices of people who are affected by COVID-19, and I guess there is a relation for um, higher risk for people who have prior diseases. So that's about it. Like this is just like understanding the basic facts of COVID-19. And then in the second part of my project, I have tried to apply machine learning models to predict confirmed cases and deaths in next 14 days. So I have used scikit-learn to apply a few of the models. So it's the same data set that I've used here. Then I try to see the shape and like if there are any null values and data types of each feature. And then I have tried to compute few facts here, like the total number of countries with the disease of spread and total number of confirmed cases around the world and recoveries and deaths around the world, what are the active classes, and on each per day numbers here, and what are the cases in the last 24 hours. So this data set I have imported yesterday. This is updated as of yesterday, which is like 5/5 to May 5th. So I am hoping this is the latest I could download from Kaggle. So and then I try to visualize the data here. So the approach that I've chosen here is to calculate the number of days since the pandemic was announced as global pandemic, and then I think it's 90. Oh, I think I'm showing the old file. Let me come to the yesterday's file. Oh yeah, so we have 103 days until today, and this is a pattern of confirmed cases over the date. So, and then I've grouped this data set as we can see. This data set has 20,000 rows in it, and I want 21K rows in it with 8 features, and I wanted to group this data set into date wise. So this is where I grouped it, and then so once I grouped this, these are the this is a pattern of confirmed and recoveries and deaths, and as I can see, as the curves are flattened since last week, which is the good news. Some other few graphics and the graphical representations and country-wise analysis. So here I wanted to do different countries, and this is a pattern of this disease. In different countries, it is pretty evident that disease is spreading in the same manner everywhere. But if the particular country is following a pandemic controlling practices rigorously, the results are evident in the graph. Like here, the Italy and no, not the Italy, the China and Germany and Iran has like having these numbers going down, which is good. Except the US is still going up. So, and then, yeah, so coming to the ML methods, the clustering of countries, I wanted to group the countries who are at different levels of risks. And there, as we see, there are 222 countries who are impacted with this. So I used elbow and Silote score method to try to get the good amount of clusters, good number of clusters, and it, as we can see, 3 or 4. I tried with 4, but that doesn't make much sense. So I tried, and then I tried with 3 number of clusters using k-means clustering method. And this is a summary of clusters of each country. Is US as in the top, and other severe countries are in the cluster second, and the less severe countries are grouped under cluster 0. Here is the picture of it. Okay, that's the cluster 0, cluster 2, cluster 1, and cluster 0, which are like moderately affected, severely affected, and worsely affected. And then the prediction of confirms and death cases in next 14 days using regression models. I've mostly used linear regression. First, I tried predicting using linear regression, which is clearly underestimated the results. I can say this with the evaluation method as RMSE. As the number is too high, the RMS mean square error number is too high, and we can clearly see it's underestimated. So and then I tried logistic regression. I know this is not a best way for predicting like the continuous numbers. I still tried just to understand how this is gonna apply to this data set. And this is the RMSE score. This is not good either. And then I tried random forest regressor model. It actually got trained well, but to my surprise, it did not predict well. When I predicted all the numbers, like it's just a straight line. I am still figuring out why is it predicted the same number for next 14 days. Okay, and then I tried SVR method with polynomial and degree 3. I tried with 5, it took too long. I don't know if that's because of my computational power. RBF is not haven't predicted well. It's just predicted the straight line. So this is the best parameters that I could give for the model to train better. And this is the prediction line, which is better than any one that I tried earlier. And so this is the forecasting after I train. Okay, let me talk about the test and train subsets here. I've used 90% and 10%. What is it? Yeah. So this is where I split the data, 90% for training and 10% for test. Okay, so this is where I forecasted the confirmed cases for next 14 days, which is still going up. So the prediction shows that we are gonna have 3 lakh more cases in next 14 days, or 3 lakh, which is not a good thing to know. And then I trained a different model for deaths, predicting deaths with using the same polynomial and degree 3. And this is also done pretty good here. And this is again forecasting deaths in the next 14 days using the trained model. And the deaths are here. This is also this is also an increasing number of graph. So if I compare, as we can witness already that this VM has done better than other, we can also say it from other square root RMS's numbers, which is like pretty good, which is smaller than any of the above graphs. So this is good. So I finally like concluded that SVR did better than any other models for this data set. So that's the conclusion, that of course the growth of confirmed cases and deaths seems to have slowed down since past few days, which is really a good sign. Hope this goes like this for the brief period. And I also understood that COVID-19 does not have very high mortality rate, as we can see, which is the most positive takeaway from this analysis. Mm. And the countries like USA and Spain and United Kingdom and Italy are facing some serious troubles in containing the disease, showing how deadly the negligence can lead to. So there's a need of our to perform these pandemic controlling practices like testing, contact tracing, and quarantine with a speed greater than the speed of disease spread at each country level. So that's my conclusion from this analysis. If you have any questions, and I can answer them now.
Okay, thank you, Soumya. I have some comments. First of all, you did some very good visualizations and general data science exploration.
Okay.
For historical data, I think for all of your ML models, you should go back 2 weeks for period to date ground truth. So even though it's interesting to look at projections for the following 2 weeks in order to validate and be able to have valid metrics, you're going to need to go back to the last week of April and have a section in your notebook for period to date, year to date. Okay.
Okay.
And so that should end as of May 7th or May 5th rather than begin. So what you're doing right now is training on data up till now, projecting into the future, and we don't have a way to actually validate that, or we won't for another 2 weeks.
Oh, gotcha. Yeah.
Looking at the Kaggle, looking at the Uncover kernels that are in Kaggle, one thing I would ask you to do is make sure you cite any kernels that you're following in terms of using examples or using the actual tasks that are specified in other kernels. So anytime you're, even when you're reproducing a kernel from scratch or learning what someone else did and it gives you an idea and you're implementing it yourself from scratch in Python within this one notebook, unified notebook, you should cite your source. So make sure that in line you're citing your source so that just as you would in a slide deck or a LaTeX or Word write-up, you have your citations in line. Okay, and they should be in proper APA format, just as they would for just as they would for a Word file. And if you're familiar with either BibTeX or Word managed sources, you can generate those separately and paste them in. That's fine. However you actually manage using Zotero, using Word managed sources, BibTeX, or Mendeley, any of those is fine. But make sure you cite them properly. Okay.
Sure.
Now, can you go back to item in your original Uncover, if you could go back to item, I just want to confirm, all of these are just exploratory and descriptive statistics, right? None of them are actually based on any predictive model.
Yeah, you're right. You're right.
Okay.
Yeah.
Okay, so so just make sure that sort of in your combined overall notes and notebook and your write-up that all of these are documented as such. And then, so I think the choropleth maps are interesting. Some of what would be interesting in the scope of 732 would be for you to look at predictive models. So you might discuss possible epidemiological spread models or other kinds of models and the role of those. I'm sure you've seen some kernels that look at spread models.
Okay.
Okay, some of them are, for example, using deep learning methods such as recurrent neural networks. So that would be RNNs and LSTM, long short-term memories. And as I said in my recordings, those are beyond the scope of this course, but that's something that you can discuss in the context of mapping.
Okay.
So finally, could you please go back to item 44 in your second note?
Yeah.
So all of your predictive models are based on extrapolation, or if I understand correctly, they're based on regression, but I didn't quite understand how you're using the classification model. You said you used logistic regression, and you are correct. It is not the best for a predictive model, but are you doing that on a case-by-case basis and then aggregating the result?
So this I used SVR, support vector regression, to train this model too. So this is not a classification, though. This is regression.
Oh, sorry. I had the wrong number. I'm mixing two things. I am interested in asking about SVR, but I meant the one right before that, the logistic regression.
Logistic regression. Okay. Yeah. I tried logistic regression here, even though I know this is not a good, I know this is used for classification. I just want to see how this works on data sets. I know this is not good fit here.
But I just want to make sure I understand. So I agree that it's not the best for this, but I want to understand what your input is for this.
Or the input. So the okay, so it's the same data set that I've used, like the number of confirmed cases and deaths, and in this case, number of confirmed cases. So it's going to be a number, just a continuous number of.
But is it? Can I see the independent axis under 38? If you could scroll up, please. The other way.
Okay.
Okay. So you have.
Yeah.
Sorry, not that one. That's linear regression. Can you go down to? Yeah. Okay. Right. So are you giving it the daily number of confirmed cases as input and
Yeah.
using that to fit? Okay. Okay. So this is not a case by case. You're feeding in features of each case and classifying it as confirmed or not and trying to predict it for each case. It's not a simulative model, right? Do you see what I'm asking?
Yeah.
If you're using it to predict based on a simulative model, you don't know the outcome of each case, but it's
Right.
basically projecting the outcomes of testing.
Yeah, I understand. Yeah, I get that what you're asking. So yeah, this is not a case by case. So prediction is just the number of cases that gets increased on every day.
Okay, so I'm trying to understand if you're doing logistic regression. Let me see here what the. So make sure you have a legend, because your blue line is your fit, right? And
the blue line is the actual confirmed cases,
actual. Okay, right.
Predicted.
Okay. So clarify your. So have a legend for each graph.
This one has the legend, if you see it here.
Oh, there it is. Okay, okay. So I would clarify the use there Okay, just to make absolutely sure, because I mean, I can read in your code what you're giving as input features, but I don't think you're very clear on how you're using those input features. So if it's not a case by case, right, how are you getting a meaningful output, right? If you're using it to predict, I think what you're, if I understand correctly, what you're trying to do is use the logistic curve to actually predict the confirmation curve, right? Um,
Yeah, yeah, that's
okay,
right.
okay. Okay, so the last remark, so I'm going to email these to you so that you have these notes to go by, and these are things to clarify in your, I put this in the group chat. The last item, and I think probably the most important, I am actually very interested in the way you used clustering. How many countries did you have for clustering? I'm sorry to skip over that, but you in your unsupervised phase, you were able to get 3 emergent clusters that are actually very meaningful, and you showed actually the cluster separation. That's a good result. How many countries did you include in your study?
We have 222 number of distinct countries that are affected by this. So
Hmm.
it's 222. I'm just trying to find where I
And
mentioned that. There are 222. Yeah. So the total number of countries with the diseased spread is 222, which have been used for this clustering.
okay, so you're just showing the top ones in that window below. Is that right? You had a ranked list.
Oh, right. Yeah. Yeah. That's right.
This ranked list in
Yes.
this
Yes.
block. You're just showing the top. How many?
Yeah. One like 15 or 10.
10.
Yeah. Yeah.
Because it. Well, I count 15 here, but
Yeah. Yeah. These are 15. Yeah. Yeah.
it's 15. Okay.
Yes.
All right. Okay, and yet you also still got only 3 clusters. Even so, is this 15 being clustered, or just showing the top 15, and we're seeing a lot of superposition in this?
No, these are the like entire number of countries. These are not just 15.
These
This
are the
is
entire number of countries. Okay,
yeah.
if these are the entire number of countries, you probably do need to um, use a smaller glyph
Okay.
and possibly enlarge the plot a little bit. So adjust matplotlib to be able to show more
Okay.
countries.
Gotcha.
Okay. So so in clustering experiment. Okay. And my final comment, you'll see, which is number 5. Because we know that the actual epidemiological spread model follows some kind of exponential because of R0, right? Because of um, the actual um, spread rate. Um,
Uh-huh.
did you consider using any exponential kernel SVM?
SVM.
So you used SVM. You used
Right.
linear and polynomial kernels.
Right.
The linear kernel is understandably uh, is going to peel away from the actual curve. Um, I know of at least one um, kernel, which we covered, which is the radial basis function kernel, the Gaussian RBF, because that's basically a squared exponential kernel. And that is built into scikit-learn. So I think it would not be too hard for you to just add that as a result,
Okay.
and see if that fits better. And if it doesn't, then we at least know that even if we do use a kernel capable of representing um,
Okay.
exponential increase or an exponential trend, because we know it's not linear, and we know that polynomials are actually going to be ill fit as well because of the basic reproduction number being greater than 1, right? For any kind of epidemic or pandemic. So that's just a general thing that we can look up in terms of epidemic modeling. And if you are following the actual Kaggle discussion boards and kernels, you might take a look at that. But my suggestion is you either just try exponential kernel regression and see how it does, or you look in the kernels and see if anyone is using any other one. And you're certainly fine to follow someone else's sort of practice, but just conduct the experiment for yourself and reproduce that result for yourself to apply what we've studied in 732.
Okay, sure. Yeah, sure.
Okay, so I'm going to paste all of these recommendations to you. Please make these modifications to your notebook before you submit your final version. And I have just a couple of follow-up questions for you. So my standard questions are of machine learning methods and practice, including data cleansing. What did you find to be the most technically challenging aspect of this whole project?
I would say applying machine learnings and predicting the results would be, I mean, writing the code might not be very difficult because we get the snippets from outside, but trying to understand what it actually does behind the scenes is a challenging task for me.
Mm-hmm. Okay. And of machine learning topics, which ones did you learn the most about by doing this project?
Oh, this one I've learned about SVR, how using the SVR, because as we know, SVM is mainly used for classification, but I try to use the SVR for this model, for this data set, which is like quite interesting to understand what happens behind the scenes. Yeah.
Okay. Finally, what would be your top priority for future work? Because you explored many directions, some of which were salient to data science, but tangential to machine learning. Of your machine learning notebook, especially, what would be your top priority if you were continuing this project in a independent study or other course?
Yeah, from your suggestions, I actually understood that there are like advanced machine learning techniques that can be applied for exponential growth of pandemics like this. So that would be my priority, to explore more on the Gaussian, the kernel for exponential trends, and RNN and LSTM, as you just suggested. That would be my next advanced.
Right. So only one of them, to my recollection, did we cover in this course. The others I alluded to, but would be sort of an advanced topic to study on your own or in an advanced course. I do have a lot of research students, and I'm a time series modeler, so I have done a little bit of epidemic modeling with Dr. Scolio in the electrical and computer engineering department. And in our research, we have used different kinds of models, including stochastic differential equations and some sort of my specialization area is more the recurrent neural networks. Okay, good work. Please make the requested changes to your notebook and updates. And I think this is a good project and a well executed project as well. So
thank you for your time and like taking time for suggesting me more.
You're welcome.
Good things. Yeah, thank you.
You're welcome. Hope everyone in your family as well. Okay, thank you, Luis, and thank you, Ryan. Ryan, do you have any questions? Or Luis, do you have any questions?
My main question is with the unsupervised task. It seems like only the U.S. was in the one
class,
cluster, cluster 0, and is that just because of the confirmed deaths right now, or confirmed cases? Okay.
Yes.
Versus deaths. Okay. Okay.
That's the only country that's been clustered for the higher number of confirmed cases.
So I wonder are you able to? I saw that you were doing some in the Uncover notebook. You were looking at what regions would need more like beds and more supplies.
Ventilators, yeah.
Yeah.
Yes.
So is there a way that you can also add that in the future? For is that data available for a lot of countries, or was that really hard to get?
I would see if they have country-wise shortage of ventilators. Um, I will have to explore more on this data set. If I think we have a state. I think we have within US. I think we have state-wise. Do you want to do within the US or?
Yeah. So that would just be another clustering graph that I'd be interested in, is cluster them based on the severity of how how desperate they are of ventilators, using the different features you have for, I guess,
Right.
case the states.
Okay,
Because
sure.
that would answer questions about that are of a predictive nature or an interventional nature, right? When we're clustering based on outcomes only, it tells us about what outcomes are similar, but it doesn't allow us to form direct hypotheses about attribution of cause, right? So if we're trying to do any kind of causal modeling, we need to include other statistical variables. And just in conclusion, first of all, let me give Ryan an opportunity. Do you have any questions for me or for Samia?
No.
No,
Yes, Ryan?
no, I didn't have any questions.
Okay,
Curious.
Ryan, since you were sort of interested in seeing what a presentation, I just wanted to make one comment. In this course, it's not expected, Samia has kind of gone over and beyond expectations in visualization. It's not expected that there be extensive exploratory or descriptive modeling. It's expected that the focus of the project would be primarily on machine learning, supervised, unsupervised reinforcement, and other aspects of learning, mostly classification, regression, predictive applications. In a project like this, the predictive aspect would be important, and uses of clustering. So using multiple techniques is definitely encouraged, but in terms of visualization, that's not a requirement. That's kind of an extra. In my data science course, that would definitely be expected, and it's part of, and in fact, machine learning less so. So I hope that's clear from sort of our discussion here. I'm going to ask Samia if it's okay with you to actually post this recording for students in the class to look at, since you are the first student to present and some students might want some guidance. Would that be okay with you, Samia?
Yeah, of course, of course. Yeah.
Okay, thank you. And so one thing I just wanted to conclude with is students may present using a walkthrough of a Python notebook. Many students choose to use PowerPoint or PDF slides using sort of a LaTeX template. Those are all fine. If you do use a Python notebook, it's also appropriate to use screenshots of specific code blocks or results. So make sure that if you do make slides, that you actually screenshot the right result blocks, including the graphs and things and tables that come out. And if you walk through, make sure you actually do present graphs with legends and with inline literate programming style comments or explanations the way Samia did. So that was well done. Okay, and finally, make sure you cite your sources just as always. All right, thank you all.
Sure, thank you.
All right, I'm gonna sign out now. Thank you.
Thank you.
Thank you, Luis.